All right, so we're gonna go over some basic definitions and examples with simple probability, kind of setting up the idea, and then looking at it in some examples. So for starters, when we talk about probability, oh no, uh-oh, there we go. Sorry about that. When we are talking about probability, we're talking about the study of chance or the likelihood that an event is going to happen. So it's not telling you for sure what will happen. You don't know anything for certain, but it's giving you some idea about the odds. And we see probability all the time, all around us. Some examples, like you could see like probability in the weather, there could be a 50% chance of snow, which means it might or might not snow. It doesn't tell you for sure what's happening, or you could have a 1 chance in 10 of winning the lottery. So when we talk about probability, we're saying, will something happen? Is it definitely going to happen? Is it definitely not going to happen? Is it likely or unlikely? So we can use terms like qualitative terms, or we can use quantitative numbers, and we'll see both in this video. So to just see it in an example, we can talk about probability in regards to picking a bag. So in this problem, we're given 3 bags, and we're told that one of the 3 bags to the right contains candy, and the other 2 contain sand. So to make that clear for myself, I labeled them candy, sand, and sand. And this question right here, number 8, says, suppose you choose a bag without looking, circle the phrase that best describes your chance of choosing the bag that contains the candy. And it could be not very likely, or a sure thing. So if you look back at this picture, I know it's not a sure thing because there are 3 bags and only one contains candy. So I know it's not that. And it's also not very likely because it's only 1 in 3, which means it's less than 50%. I have a less than 1 in 2 chance of getting it, which means it's not very likely. So instead we say it's not very likely. So you can think about that like quantitatively in regards to being like 1 out of 3 bags is not very many. Or you can just think about it, if you were the person picking a bag, do you think you would pick up a bag of candy or sand? And because 2 have sand, you would probably pick up one with sand, which means picking up the one with candy is not very likely. Question 9 says, suppose on your first try you get a bag of sand. Circle the phrase that tells your chance of choosing the bag that contains the candy on your second try. So this question is interesting because they tell us something happens first. First, you get a bag of sand, which means the second bag we pick can't be that bag of sand again. In other words, if we started with these 3 bags, we can now cross out one of the bags of sand because that has already been chosen. Now, when I choose my second bag, there's only 2 bags I can choose from, the candy bag or the sand bag. And the candy is now 1 out of the 2 things I could choose, so we say that as a 1 chance in 2. So this is different because there are only 2 bags I'm considering in this one. And number 10 is an extension of that. Number 10 says, suppose on your second try, you also get a bag of sand. How would you describe your chance of choosing the bag that contains the candy on your third try? So the first thing here that was important is they said the second try also was a bag of sand, which means I can cross out the second bag of sand because it was already chosen. And now there's only 1 bag left that I can pick, and that's the bag of candy, which means I will absolutely pick that. And there are a couple different ways we can represent the idea of absolutely being picked. We could say it's a 1 chance in 1, which means out of all, there's 1 option in total, and this is the one that matches that. We could say it's a sure thing, or that it'll definitely happen. We could say in regards to percent that there's a 100% chance. Or you could say the probability is 1, and that's just a number. And we can say the probability is 1 because when we use quantitative terms, when we use numbers to describe probability, it ranges from 0 to 1. And we can represent that in fractions, decimals, and percents. So here we showed how we can kind of explain it in words. On the next slide, in the next examples, we're going to show how we can explain probability in numbers. So when we write probability as a number, when we say what are the chances of something happening as a number, that number is always going to fall between 0 and 1. which means that probability could be written as a fraction, because we know fractions, proper fractions, are between 0 and 1, like 1 out of 5. We could also write them as a decimal between 0 and 1, like 0.2. And we could also write them as a percent between 0 and 100%, such as 20%. And this right here means that everything you already know about moving between fractions and decimals and percents and vice versa stays the same. We know that we can interconvert between all of these using division, moving decimal places, and you can still do that with probability, because probability really is just an example of where we see fractions in real life. And every time when we solve for probability problems, we're going to kind of think about them in the same way. So in the study of probability, each possible event, everything that could happen, is called an outcome. For example, in that last thing with the 3 bags, each bag I picked, that was an outcome. A particular outcome, such as a pointer stopping on $10, is called a favorable outcome. So the one that we want to happen is the favorable outcome. Come back to that in an example. And we write the probability of a favorable outcome as a fraction, where the probability of the favorable outcome occurring equals the number of favorable outcomes over the total number of possible outcomes. So we can write that as a fraction where we look for what do we want to happen, that goes on top as a numerator. What are all of the things that could happen? How many things could happen? That goes in the bottom as our denominator. And we can set up any fraction that way, and once you have a fraction, you can turn that into a percent or a decimal. We're going to see it in a few different examples now. So just to show one more time how you write probability as a number, probability is something that ranges from 0 to 1. And the numbers between that describe the chance that an event may occur. And this means if an event's impossible, you might have seen this before, as there's a 0% chance of something happening, well, that's a probability of 0. If an event may or may not happen, if you look at this middle circle here where half of it's shaded and half of it's not shaded, when they're equally likely, that's a probability of 1/2. And you can think about that as being equally between 0 and 1. And lastly, when an event is certain, when an event will absolutely happen, it's going to have a probability of 1. And you might have seen this before as 100%, but if you wrote 100% as a decimal, that would also equal 1. So now, using that cue about favorable outcomes, about writing probability of favorable outcomes as this fraction, we're going to look at a few examples. In this example and the next example, we're looking at this spinner here. And this question asks us, what is the probability that the pointer will stop on $10? In step 1, the first thing we ask ourselves is how many total possible outcomes are there? And because this spinner is split up into 5 sections, we can say there are 5 possible outcomes. So that was the first thing we did. We know the total number of possible outcomes, which is in the denominator here. So that's something I needed to know. In the numerator, I'm going to have to fill in the number of favorable outcomes. So I have to look back at my spinner and ask myself, out of these 5 options, which one of these match what I want to happen? And my problem says what I want to happen is the probability to stop on 10. Well, only one of these has a number $10 in it, so there's only one favorable outcome. Now that I have those 2 pieces of information, I can put that together as a fraction, where the number of favorable outcomes, that was 1, because only one spinner had a 10 on it, over the number of possible outcomes, that was 5, because this was split up into 5 pieces. So we turned that into a fraction, and we got 1/5. And you can write that as a fraction, like 1/5, or the equivalent percent, which is 20%. One more example with the spinner problem. This question is the same spinner, but a different question. It's looking to find information about a different probable outcome. And it asks, what is the probability that the pointer will stop on $1? So we still have 5 possible outcomes here. So our denominator stays the same because our total number of possible outcomes didn't change. But now I'm looking for my number of favorable outcomes. And in this problem, favorable outcomes means sectors that have $1 on it. And I notice that there are 2 sectors that have $1 on it, which means I have 2 favorable outcomes. So now my numerator in step 2 becomes 2, because there are 2 different ways I could get $1. My number of possible outcomes stays the same as 5, because my spinner still has 5 spots on it. So now in this problem, I write that as a fraction 2 over 5, which I could write as the equivalent percent as 40%. If you were to write that in words, that says on the average, 2 spins out of 5 will stop on $1. And what this means on average is if you spin it 5 times, you won't definitely land on $1 twice. You don't know that for sure. But you do know that that is the most likely thing that will happen. That's what's going to happen on average. So probability is kind of giving you those like ballpark estimates. Going to look at a different example. Instead of looking at a spinner, in this example we have a number cube. The problem says a number cube has 6 faces. Each face is equally likely to be up after the cube is tossed. With one toss of the cube, what is the probability of? And then we're given different events. So thinking about probability as our favorable outcomes over possible outcomes, all of these have the same number of possible outcomes, and that is 6, because there are 6 different things that could happen. And now in each problem, I just have to find out the number of favorable outcomes. So what is the probability in A of rolling a 4? If I look at my die, only one of the sides has a 4 in it, so I only have one favorable outcome. So the probability of rolling a 4 is 1 out of 6. 1, my number of favorable outcomes. 6, my number of possible outcomes. B asks us, what is the probability of rolling an odd number, which is 1, 3, and 5? There are 3 different cubes with odd numbers, which means I have 3 favorable outcomes, that's my numerator, and there are still 6 possible outcomes, that's my denominator. And just like when we work with other fraction problems, when we have fractions that we can reduce, we do, and 3 over 6 reduces to 1 over 2. C asks us our probability of rolling an even number. Well, I see here my even numbers are 2, 4, and 6. So there are 3 even numbers with 3 favorable outcomes and 6 possible outcomes. Again, I can reduce that to 1 over 2. And lastly, what is the probability of rolling a number divisible by 3? In this one, I went through each one of my options and asked myself which ones are divisible by 3. 3 is divisible by 3. 3 divided by 3 is 1. 6 is divisible by 3. 6 divided by 3 is 2. Those are my 2 options that are divisible by 3. So I have 2 favorable outcomes over 6 possible outcomes. 2 over 6 reduces to 1 over 3. So in all of these problems, I can express probability using the shortcut here, where a probability of a favorable outcome equals the number of favorable outcomes over the total number of possible outcomes. We're going to look at 2 more examples of ways this could show up. So we've seen it as a spinner, we've seen it as a cube, we can also see it as a deck of cards. In this problem, I have 5 cards, which off the bat tells me I have 5 possible outcomes. There are 5 different cards I could draw. Number 9 says, suppose the cards are face down, which means I can't see any of them. I randomly choose one. What is the probability that the following events happen? The first one asks, what is the probability I draw the King of Hearts? Well, looking at these 5 cards, those are my 5 possible outcomes, and I only have one favorable outcome. I only have one King of Hearts. If we think of probability as favorable outcomes over possible outcomes, that means 1 out of 5 or 1 over 5, which I wrote as a fraction, and I could always write that as the equivalent percent, which is 20%. B asks us, what is the probability I draw a face card? A face card is any card that doesn't have a number on it, that has these faces on it. I see the king and the queen are both face cards, which means there are 2 favorable outcomes, so that's my numerator, out of 5 possible outcomes. So that's my denominator. So my probability is 2 out of 5. So I could write that as a fraction. An equally good answer would be to write it as the percent, 40%. Unless the problem asks you to write it as a fraction or asks you to write it as a percent, both of these are correct answers. Next, C asks us, what is the probability that I choose a number card? Well, I see here 9, 5, and 2 are all number cards, which means I have 3 different number cards. I have 3 favorable outcomes over 5 possible outcomes. So the probability is 3 out of 5, or 60%. Lastly, I'm asked, what is the probability that I draw a heart? Well, there are 5 cards here, and all 5 of them are hearts, which means I have 5 favorable outcomes out of 5 possible outcomes. Well, 5 out of 5 equals 100%, and it also equals 1. So any of these are favorable outcomes, or any of these are correct probabilities. Notice that in all of these, I use fractions or percents that were between 0 and 1, because probability ranges between 0 and 1. 0 again meaning the event is impossible, it won't happen. 1 saying it will definitely happen. And probability falls between 0 and 1, and it tells us about the chance of it happening. This is our last example. We can use probability always to describe favorable outcomes, and we can also use it to describe random events. So we've got 6 statements here that we're going to go through, and we're going to ask ourselves, where does this fall in my 0 to 1 range? This question asks, the first question says, somewhere in your state, a baby will be born today. And it's our job to say, what's the probability of that? Well, we know babies are born in every state every day. So there's a 100% chance that that's going to happen. So I'm going to write that that's a probability of 100%, which also equals 1. The second question says, the next baby born in your town will be a girl. Well, there's a 50% chance it will be a girl and a 50% chance it will be a boy. So these next two are both 50%. There's a 1 in 2 chance for each one. So I could express that as a percent or a fraction, both numbers between 0 and 1. Question 4 says, you will fly to the moon tomorrow. Unfortunately, none of us will be flying to the moon tomorrow. So that is impossible. It won't happen. That's a probability of 0. The next one says a flip penny will land heads up. Well, a penny could land either heads up or tails up, which means there's a 1 in 2 chance this will happen. 1 as our favorable outcome, 2 as our number of possible outcomes. So that's a 50% chance, or 1/2. And lastly, our last example says some place on Earth is experiencing night right now. Well, we know on Earth that everywhere, at all times, there's night somewhere, and at all times there's day somewhere. So there's a 100% chance that somewhere on Earth has night right now. That's definitely happening. We're certain about that. So that's 100% or 1. So all of these show that we're using this range of 0 to 1. Sometimes when we see these percentages, we think that probability is out of 100, but probability is out of 1. 1 just equals 100%. But if you think of converting percents to decimals, then it really is between 0 and 1. So to just put it all together, to remind you again, probability can be used to make predictions. Whenever you see probability, it's easy. Sometimes we think, oh, that's telling us if something will happen. It's not telling you exactly what will happen, but it can tell you how likely something is. So it's not exact, it's giving us ballpark estimates. It's saying on average. And you can calculate the probability from any problem knowing that it is a number between 0 and 1. You can express it as a fraction, percent, or decimal. And you can write it as a fraction easily by saying that the probability of a favorable outcome, again, that's talking about the thing that you want to happen, equals the number of favorable outcomes over the total number of possible outcomes. You can go back and watch that section where we went over the number of favorable outcomes over total number of possible outcomes to quantify probability. But that is it for simple probability.